Hi everyone, today we are going to discuss about the real-time operating system. Operating system, services, goals, modes and the structure of operating system we are going to see. Before going to that one, first we'll see what is operating system. What is operating system? Operating system is an interface between a computer user and computer hardware. It is going to become a middleware between the computer hardware and the computer user. An operating system is a software which performs all the basic tasks like a file management, memory management, process management, handling input and output, and controlling the peripheral devices such as the drivers and the printers. This is about the operating system. Operating system examples are Android operating system, Microsoft operating system, Linux, Red Hat. These are many operating systems are there. Now we'll go for the OS services goals. First we'll discuss about the normal operating system, then we'll go for the RTOS. First we'll see the real-time operating system services and the goals. The OS service goals are the perfection and the correctness during a service. We'll go for the first one, that is going to facilitating the easy sharing of the resources as per schedule and allocation. Here, the resources means processors, memory, I/O devices, pipes, sockets, system printer, keyboards, display, printers. These all are the resources which processes request from the OS. The processors are going to be requesting these resources from the OS. OS is responsible for allocating these resources to the processors for the execution. No processing task or a thread uses any resources until it has been allocated by the OS at a given instance. This is about the first service of the OS. Second one is a easy Second one is facilitating a easy implementation of the application program with a given system hardware through the system software. It is going to provide a easy implementation because everything will be already there in the OS for the application program. See, take an example of application program. You are going to use the what? Zoom application or a Cisco WebEx. These are the application programs. Directly we are going to install in your system, directly we are going to use those things, and through that application you are going to access the keyboards and other hardware devices of the system. That accessing of the hardware devices for the application programs is going to be facilitated using the operating system. Next is optimally scheduling the processes on one or more processors. That is, processors means CPUs, which are available in the system by providing an appropriate context switching mechanism. First, we will discuss about the scheduling. Scheduling means what? Allocating the processes to the processor. Processor means CPUs. See, we will discuss about the dual core processor. Dual core means two cores will be there. Two cores will be allocated for the processes for the execution. That is the work of scheduling. Many scheduling algorithms are there. First comes the first, shortest job first. Through these algorithms, the operating system is going to be allocating the processor to the processors, and it is going to provide an appropriate context switching mechanism. Context switching means switching from one task to another task. That is also be that should also be a less for the moving from one task to another task. Next, maximizing the system performance to let different processes, that processes or it may be task or it may be thread, share the resources most efficiently with the protection and without any security breaches. Without any security breaches, it has to work. It has to give them more performance. and more resource sharing for the system. Next, providing the management functions for the processors, memory, file, physical and virtual devices and IOs, and for the other functions for which it is designed. It also provides a management functions for the all the processors, threads, tasks, memories, file system, physical devices, IOs, everything. Providing a management and organization functions for the IOs devices and the file-like devices. For these all things also it is going to provide the management functions. Providing interoperability of the applications on different networks. Interoperability means that the Zoom is going to be working on this uh, Windows system as well as in the Linux system. That facility also it is going to be providing. That type of the interoperability is provided by this operating system. Providing a common set of interfaces that integrates various devices and applications through standard and open system. It is going to provide the best interface for integrating the various devices and applications to the standard and open system. Provide a easy interfacing and management functions for the network protocol and the network. See, whenever you want to connect your device with the network, it is going to provide the easy functions for connecting the network. You can directly plug in and you can use the internet. That facility the operating system will provide. Providing the portability of the applications on different hardware configuration. See, if your system is 8086, you can move to the 80386, 486. That hardware may be anything. This you can use your applications on the different hardware. That facility is going to be provided by your operating system. Next, we'll move for the user and the supervisory mode structures. First, we'll go for the what is the user modes and the supervisory modes. The processor in the system running in two modes. One is the user mode and the one is the supervisor mode. See, when using a OS, the processor in the system runs in two modes, that are user mode and supervisor mode. There is a clock in the system that called a system clock. At every clock tick, the system clock will be there. There is an interrupt. It is going to create one interrupt for each system clock ticks. On the interrupt, the system time updates. The system context switching to supervisory mode will be occurring from the user mode. After completing the supervisory functions in the OS, the system context switching back to the user mode. If first it is going to execute the supervisor mode functions, afterwards it is going to come back to the user mode functions. On the interrupt, the system time updates. The context switching from the supervisory mode will be occurring from the user mode. Next, what is the exactly user mode means? User processes are going to be permitted to run and use only a subset of functions and the instructions in the OS. Only limited functionalities will be provided for the users. Only limited subsets of functions are going to be provided by the users. In user mode, only that things can be done. Use of the OS functions in a user mode either by sending a message to the waiting process associated in the OS kernel space or by system calls. See, whenever you want to execute the supervisory mode functions, you have to use the system calls. Through the system calls, you can call the supervisory mode functions and execute those things in the kernel space of the OS. Then you have to come back to the user mode. So the execution of the user mode functions are very slow because of the time consuming. It is going to be switching from the user space to the kernel space, then executing those functions and coming back. Next, use of the hardware resources including the memory is not permitted without the OS making the call to the OS function. That is a system call. Without any system call, the user mode cannot use the memory resource. A user function calls which is not a system call is not permitted to read or write into the protected memory allocated to the OS functions, data, stack, heap. These all the things will be there in the process. For each process, you will be having the data stack and the heap. That cannot be used until and unless you have taken the permission from the OS or you are using the system call. Without system call, you cannot access these things. That protected memory space called the kernel space. Hence, execution of the user functions calls is slower than the execution of the OS functions due to the need to spend the time in the first checking the access permission to the protected space. Next is the supervisory mode. This is also called as a kernel mode. In this one, directly the execution of the functions will be done in the kernel space. The OS runs in protected mode. The privileged functions and the instructions is protected mode. That are the privileged ones and the OS is only one permitted to access the hardware resources and protected area of the memory. The kernel space functions and the processes execute faster than the user space functions and the processes. Only a system call is permitted to read and write into the protected memory allocated to the OS functions, data, stack and the heap. The example for this is a RTOS example, improving the system performance by running the application program threads in the supervisor or the kernel mode. Next, we'll move for the structure of the this operating system, how it will be there. See, last one will be our hardware. Here, the down will be our hardware. Next will be our operating system. Next will be our system softwares. Last one will be our users. Here our users will be there. The hardware is going to be contacting to the OS through this hardware OS interface. The OS is going to be contacting to the system software through the OS interface. The user is going to be contacting to the system software through the APIs. Through the APIs, they are going to be contacting. Sorry, this will be a down one because user is going to be contacting to the system software is going to be contacting to the OS is going to be contacting to the hardware. See, what are the things are there? We'll see one by one. First, we'll see the hardware one. The processor, memories, buses, interface circuits, ports, physical devices, timer, buses for device networking. These all will together comes under the hardware devices. Next is the hardware OS interface. This is going to provide the interface to let the functions execute on the given hardware. It is going to provide the interface for the hardwares like a device drivers. Whenever you want to use the devices, that device driver is important. Say if you want to use a printer for your computer, you have to install the device driver of the printer. Without that one, you cannot access that printer through your system. So that is a device drive. That is a hardware OS interface that is going to be there here. Through this one, you are going to access the hardware. Next is the OS. Kernel supervisor remote services, file management and other services are going to be handled by this OS. File management, memory management, device management, file system management, IO management. These all things will be done in this OS. Next is the OS interface. It is going to provide the interface for the above layer and the below layer. For the OS and the system software, it is going to provide the interface. Next is the system software other than the one provided at the operating system. OS may not have the functions. For example, for a specific network and for the certain device drivers such as the multimedia devices. See, OS may not contain all the device drivers. System softwares are necessary for that one. That installation is going to be done through this system software. Take an example of the multimedia devices. That is going to provide the accessing for the multimedia services. That is a thing. System software. Next is the APIs, application program interface. It provides the interface between the application and the system software so that it is able to run on the processor using the given system software. Through this API, user can access the system software, operating system and the hardware. This is through the users you can use this APIs. Last one is a user. User is a user of the system. This is about the structure of the operating system. Next is the kernel services in the operating system. Here, the OS is the middle layer between the application and the system hardware. The OS includes some or all of the some following structural units. The kernel, here kernel. So it is we are going to discuss about the kernel. Kernel, the process, memory, IO managers and the essential components of the kernel. Kernel may include the file, device management functions as a part of the kernel in a given operating system. Kernel in certain OSs is without file and device management functions as a part of the kernel in a given OS, and any other needed functions other than the processors, memories and the IO device managers, which are essential components of the kernel, are not provided for at the kernel. Only required functions of the kernels can be used, other can be left. See, kernel is a basic structural unit of an operating system. The memory space of the kernel functions data and the stack is protected from the access by any functions call other than the system call. It can be defined as a secured unit of the operating system that operates in the only supervisory mode. The remaining part and the application runs in the user modes only. Only the supervisory mode can run in the kernel space of the memory. Some of the functions is services is going to be provided by the kernel, that are process management, memory management, file management and the device management and the device drivers, IO subsystem management. These are the services of the kernel. These all are the services of the kernel. Next we'll go for the first one is the process management. The process management, what is process? Process is a program in execution is a process. We'll discuss how to manage this process. The process is going to have its own structure. Process creation, process activation, process running, process blocking, resume, deactivation, deletion. These are many stages of the process that are from creation to deletion. The process manager is going to manage the process creation to deletion of the processes. A process structure maintenance. See, every process is going to be containing the PCB, process control block. That process structure maintenance, it is going to enable the process structure maintenance and its information. Maintaining of the PCB is the process structure maintenance. Processing resource requests. The resource requests by processes made either by making a call, which is known as a system call, or by sending the messages. You can request the resources through the system call, or the by sending the messages you can request for the resources. Scheduling of the processes. Process scheduling of the processes. First come based on the first come first serve, shortest job first, shortest earlier deadline first. Through those algorithm, scheduling algorithm, processes are going to be scheduled. Next is the inter-process communication, that is the IPC. A processor synchronizing by sending the data as a messages from one task to another task. Inter-process communication is communication of the processors. It can be sent through the messages, or you can be handled that one you by sending the sockets, pipes, mailbox, queues, semaphores, are the RPC, remote procedure calls. Through those things you can provide the inter-process communication. This is about the process. Next we'll go for the memory management. Next is the memory management functions. We'll go for the memory allocation first. In this one, when a process is created, the what will be done? The memory manager allocates the memory addresses to it by mapping the process address space. A thread of a process shares the memory space of the process. The process memory is going to be shared to the threads. A memory manager of the OS. It is going to provide the security, robustness, as well as it is protected. No memory leaks and the stack overflows are going to be allowed. Memory leak means attempt to write in a memory block not allocated to a processor or data structure. That is a memory leak. Stack overflow means that the stack exceeding the allocated memory block. That is a stack overflow. These are not going to be allowed. Whenever a memory leak and the stack overflow is there, then that is not allowed for the memory manager. This it is going to handle this situation. Next is a memory managing strategies for the system, or a memory management functions in the OS kernel. First one is the allocation, deallocation. Memory allocation and the deallocation and memory management. It also restricts the memory access region for a task. That is the memory allocation and deallocation. Next is a fixed block allocation. Memory address space is going to be divided into blocks. The processes requiring a small address space allocated a lesser number of blocks. The processes requiring a larger address spaces allocated a large number of memory block. That is a fixed block allocation. Fixed block allocation means first memory is going to be divided into number of blocks. Then the process which is requiring the small address spaces, a small blocks are going to be allocated. If the process requires the more address spaces, more blocks are going to be allocated. That is a fixed block allocation. Dynamic block allocation means a division of the memory address space into fixed blocks. First, the memory is going to be divided into a fixed block as the above. The dynamic allocation here means the dynamically a memory address spaces is going to be allocated. The memory manager allocates the variable size of the blocks. It is going to be varying. A memory protection to the OS functions. The OS functions, code, data, stack are in protected memory area. It means that when a user function call attempts to write or read in the exclusive area of a memory space allocated to the OS function, it is going to be blocked because you cannot access that memory space directly. You have to use a system call. Through the system call only you can access. So the system generates an error for this one. The memory of the kernel functions is distinct and can be addressed only by the system calls. This is about the memory protection. See, kernel memory space cannot be accessed by everyone. And also in the task, some area will be in the protected mode. Only through the system calls we are going to be accessing that protected mode of the memory. Rest normal system normal calls cannot access that one. If it is trying to access, then a system is going to generate the error. This is about the memory protection among the tasks. Memory protection, sorry, that is about the memory protection to the OS functions. Next is the memory protection among the tasks. This means that task function calls cannot attempt to write or read the exclusive area of the memory space allocated to the another task. One task cannot access the memory space of the other task. That is the memory protection among the tasks. Next is the multiprocessor memory allocation. Allocation either shared with the tight coupling between the two or a more processor, or shared with a loose coupling or a multi-segmented allocation. This is about the multiprocessor memory allocation. Next is the memory manager functions. What are the functions are going to be handled by the memory manager? Use of the memory address space by a process, specific mechanism to share the memory spaces, specific mechanism to restrict the sharing of a given memory space, optimization of the access period of a memory by using an hierarchy of the memory. Remember that the access period for access periods are in the following increasing order: cache memory, primary, and the external, secondary, magnetic, and then optical. In this order only it is going to provide the accessing. See, whenever any process want to access the cache memory, then first it is going to be allocated. If it is going to requiring the primary memory, it is going to be allocated next. If it requires the secondary memory, then next. Like this, in this increasing order, accessing is going to be provided for the processors through the memory manager. This is about the memory management functions in the OS kernel. Next, we'll move for the device, file, and IO subsystem management. Device manager functions.